Everybody. This is going to be the most daring webinar, I must say, that we're probably ever going to do, because today we will actually live code. You're not going to see prepared stuff. You're going to see AI in action in systems engineering. So cut us some slack. This might work in a few minutes, or this might take a while, but we'll be sure to get there in the end. Yeah, my name is Robert. I'm one of the co-founders of SpicySE, and I have the pleasure of introducing the topic today. With me on the call is Torben, who's actually going to do the heavy lifting, and he's going to show us how he's going to Vibecode a tool connection today live in this meeting. If there's anything you would like to dive in deeper, please don't hesitate to ask questions, use the chat. And if you want to talk to us directly, you'll find a QR code in the lower left-hand corner of the presentation. Just scan that and you can book a meeting with us. And with that being said, let's get started. Yeah, so what's our commonly shared interest in this room? I believe it's systems engineering. That's what we all do, what we care about, what we love. And of course, this day and age, we can't get past AI. It's everywhere, and it will be here with us today. In case you're interested in AI, in the actual application of systems engineering, I invite you to go to YouTube and look for SpicySE webinars. We had a pretty, dare I say, cool one on AI and systems engineering, which is available on YouTube. But today we're going to add a third circle into this Venn diagram, which is the digital thread, which is also a topic that's heavily discussed at the moment. So it's about connecting tools, creating traceability through a variety of tools. And we all know that our organizations use many, many different ones, hundreds of different development tools. And what we like to do today, why we invited the session, is to show you nowadays, with the capabilities we have with AI, how easy it can be to connect tools to each other, and especially, of course, our tool, SpicySE. With that being said, let me tell you a little story about this man named John, who's happily driving down this wonderful countryside road and having a good time singing. But all of a sudden, on his dashboard, he receives a warning light. Apparently, it tells him that he has low tire pressure. So what does John do? He gets out his vehicle, he stops it first, then he gets out his vehicle, and he takes a look around his tires, and he realizes, they're all fine. Yeah, they don't look low pressure or flat at all. What happened here? It was a risk. John stopped his car on the side of the road, thereby potentially endangering himself and endangering, of course, other traffic participants around him. And on this little story, we would like to start today's example. So something must have gone wrong on the communication from the tire pressure sensor to the infotainment, which provided the warning to our protagonist. So somewhere along the way, some signal was wrong, and we need to make sure that this doesn't happen again. So we need to guard against that. And we're going to do that by implementing a range check module. Implementing, building something, we all know what this means. This means vModel, right? So first and foremost, we need our requirements to tell us what we are supposed to build. Then we're going to implement it, or probably someone else is going to implement it in code, hosted in some IDE like VS Code. But essentially, it's a C++ file. And then we have tests. We need to verify that what we wanted to do, we actually did. And these tests are hosted in Gtest. And then the final component, this holy trifecta of requirements, tests, implementation, we all know. And we also know above that is some form of project management, looking at maturity, traceability, and of course, the connection, the traceability from the tests to requirements. And that's what we actually want to do and show you live today. How do we get from requirements, code, tests to a full traceability? using Vibecoding, using our API, and of course, well, when we Vibecode, using AI. So first, I'd like to invite you to Spicy. I've seen some names that I recognize, but for those who are not Spicy users yet, let me welcome you to the tool Spicy SE. We built this tool essentially to lower the hurdle into systems engineering. We want to democratize systems engineering. And I'm sorry to say, because I believe you're all system engineering experts in this room, but we don't only want the system engineering experts in systems engineering. We believe we can do more. We believe that everyone in a development team should have access to a common platform and model to do their systems engineering. So keeping this reduction of the entry hurdle in mind, I would like to start by pointing out 3 things really quickly. Number 1, you are still in my Chrome browser, as you can see. So to the end user, Spicy is always browser-based, which eliminates the need to install, upkeep, maintain, and do all these things. We can run it cloud-based, but you can also run it on your local server on-premise, of course. But to the end user, it's really, really easy. The second thing I would like you to feast your eyes on is that we have something that resembles requirements on the right and something that looks like architecture on the left. In Spicy, architecture and requirements are directly connected. There's no need to train and use 2 different tools or even a bridging tool between these 2. And we'll see how these 2 interact and are interconnected in just a second. The third thing that you see is that you don't see much at all. There's not that many buttons. And that is by design. We want the onboarding time to be as quickly as possible, and we want all of our users to feel extremely confident when navigating the tool. And every button that I see that I don't know what it does will deteriorate my confidence. So by making it really easy, constrained, and walkable, we actually invite many, many people to the systems engineering model to share the work. Now, but this is not the goal today. The goal is to connect this tool to another one. So let's get back to our example. From our example of our driver who had a wrong message in the dashboard, we deduced 2 things. 1, we have a stakeholder requirement. We have the stakeholder requirement that we do need warnings about low tire pressure, even flat tires. And we also saw that we produced a risk. So our driver stopping their vehicle in the middle of the street is risky. That could lead to potential injury of our driver, of other traffic participants. And we have, of course, rated that risk by severity and probability. And we definitely found out that this is a thing to mitigate. So there's a risk measure that we need to implement range checks for these sensor signals. We need to make sure that if something wrong comes from the sensors, it shall not reach the infotainment system. Now in Spicy, the next step to do is what's called a context analysis. So you see that here in the middle, we have a system boundary called the automotive diagnosis system, which is what we are building. And part of that is that stream of knowledge that we saw earlier from tire pressure sensors to infotainment. Now in Spicy, if I click on something, I see information about it. So in this case, when I want to see what goes to the infotainment system, I see that we have a signal on a logical conceptual definition. Is the tire pressure okay or not? And if we dive deeper into implementation, we have 4 signals from 4 wheels that are enums, and they go from okay to maybe a little bit warning to absolute emergency, stop the car right now. So this is our output. If we move to the input side of things, what do we get from the tire pressure sensors? We have 4, and we get the tire pressure in bars and its floats. So now, what do we know? We know what our task is. We have a stakeholder requirement to fulfill. We know we have a risk to mitigate. We know what we need to provide, and we know what we are getting. So in Spicy, again, if we select a system boundary, we see the information, the data stored inside that system boundary. So the requirements that you see here on the right directly belong to the system architecture element, which is how Spicy connects requirements to architectures. So in this case, we don't care about the 51 general requirements. We care about this one performance requirement today that we've given ourselves. And what we can do immediately, we can click on it and then see in the linkage view exactly where it comes from. So why do we have the system requirement? We have it to fulfill the stakeholder requirement we talked about. And in the red box, we have the system requirement to mitigate the risk that we found. And we'll dive deeper into these downlinked requirements in just a second. So now let's look back at our context architecture. We see there's inputs and outputs, things going in, things going out. We looked at the ones that are interesting for today. So now we're interested in what is inside. What is our, at this point, black box system actually consist of? What are the components inside? So in Spicy, what we do is we click on this level down button here, which will bring us inside the system boundary. And you will notice how the system requirements, which are now on the lower right-hand side, are going to move themselves up to the upper right-hand side. So like an elevator, we dove into detail of the model. Now you see the interfaces we defined that are now green bubbles and red bubbles. And we also see the components inside of our system. And especially you see one component, which is the one that we're talking about today, which is this range check module. And we can also see that we've given ourselves already some requirements, and these requirements are linked to our system requirement, and you've just seen how it is linked to our stakeholder requirement and to our risk that we're mitigating. So we do have a lot of traceability built already. Now what we're looking to do is, and I'll move to the Design and V&V tab. So again, the architecture, you see it here, the requirements that we saw earlier, but you see how the testing, the V&V window or view is still empty. And now we know this is a software-only component. We're going to write it as a CPP, and we're going to test it with Google Tests. So somehow we need to connect Spicy via the API to our testing framework. Now, tool integration, digital thread is more of a digital threat, haha, a joke. But Torben will show us in just 1 minute how easy we can do it using the power of AI that we have today. So Torben, please take it away. I will unshare myself and let you go ahead.
All right, thanks, Robert. So for simplicity, I will just share my complete screen because I will switch between tools. So what you see first is the same view as we saw from Robert. So I'm in Spicy as well. I'm in the same product. I see the same component, the range check component. I see what's coming in. I see what's going out. I have my requirements in the top left, as Robert already mentioned. So we have 3 requirements to ensure that the values which are coming in make sense, are valid. What I already added is in the bottom right, some designs. What designs mean here is the source code, which is performing the range check. I added a test file, that's the Gtest, so the Gtest file does already exist. And I have an executable file, which would be running the test. So that's the compiled version of the Gtest plus the source code. All right. Just to give you a heads up, I will also switch to Visual Studio Code. Here you can actually see the CPP file, that's the range check. And I created some empty files for the next step that we're going to take in Python. So the first thing we want to do is we now want to import the tests that we have specified in Gtest to Spicy SE. To do so, first of all, I am going to copy the source of the test file. And I will ask ChatGPT. That's just typing mind is like a framework where I can switch between different LLMs. I'm using ChatGPT at the moment. And I will ask it. And again, I have not done that really. I mean, I've of course worked with our API. I've done things, but I've not done exactly that thing. Please extract test names and the description comment. So in the CPP file, there are test cases defined, and above each test case, there is a comment which is describing the test case. Test. Oh, actually, I should say, please create a Python script that extracts test names and the comment in the line above the test from the following file. So let's see if that works, if that's already enough. Usually what I like to do is, I mean, prompting usually is better if you're pretty specific, but I'm a bit lazy. So usually I try to start a bit generic, and if it works, then if it doesn't work, then I become more specific. So that's the first step. Let's see if that works. And now we should be extracting. No, I don't think that worked. So you see, that didn't work very well. Please create a Python script that extracts the test names and the comment in the line above the test from the following test file. And let me see. Not sure why it didn't work. Yes, now it works. So we have 5 tests. Range check within range, below range, above range, on lower limit, on upper limit, and the comment is first test, check if value in range. Second test, check, and so on and so forth. I don't have to read everything. But this is the 5 scripts, the 5 tests that are defined in the Gtest. Into an specific element ID. That's important because if you have used Spicy before, or maybe get clear from Robert's explanation, everything is always attached to an element. So whenever I want to add information to Spicy, I have to do that to a specific element. So I have to tell the AI that I want to add these test cases to a specific element ID.
Which is the red box that we saw earlier in the demonstration.
Yes, exactly. I have to find out the ID, in fact. For every test in the Gtest file, I want to create one test case in Spicy SE. So let's say the comment in the Gtest file is the content of the test case in Spicy SE. The test name Gtest is the comment in Spicy SE. Test case. So now we have to tell the AI what the query looks like to call Spicy. There's different ways. So first of all, we have api.spicy-se.com, which is the general page with all the queries. But these are generic. These are not project specific. And then in Spicy, where I create the access token for the API, I can actually also see some examples. And I have to get two informations. One is the product ID. I can get that if I click on My Spicy and I click on the settings, and here it has the product tenant ID. And then if I click on my initials, I click on access token. And here I can create an access token to use the API. So I'm creating a second access token, and it's already given an example, but I'm not using that. I'm actually jumping into the GraphQL API documentation link here. And that has one advantage because I can add the information here. And you can see in the bottom that these queries are now project specific project and product specific. And I can now copy this. And I can say the query to access my product is this. But that was, the query was not to create a test case. So I will also let it know, always the same. A test case is the following, and this I will copy from the API website. So here's different queries, and one of them is to create a test. And I will actually copy the source code because it doesn't really work well to access the website. So what do we have? Next thing I want to do is I want to write this information to a specific element ID into Spicy. For every test in the Gtest file, I want to create one test case in Spicy SE. The comment in the Gtest file is the content of the test case in Spicy SE, and the test name of Gtest is the comment in the Spicy test case. So that should be fine. The query, let's go with the example query. To access my product is blah, 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 blah. The example query to create a test case is blah, 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 blah.
Place your bets now in the chat. Is it going to work the first time?
So I want to do both at the same time, the first and second step. Let's see. Correct test names and comments from the file. Use GraphQL to create test mutation to create new test case in Spicy SE. So that works. I can see already it's having the right information, at least for the URL. That's the URL that we're working on. I have to add the architecture element ID. That's actually something I can check because the architecture element ID is in the information in the progress panel. So if I click on that orange icon, which will open the progress panel, and in the top left, I get this little information, and the ID is 14. So let's see if that works.
Just a small hint if you're trying this at home. It needs a while to write the whole code. If you're impatient and you click copy before it's done, you might only get half of the code that your Vibecoder will give you, and then you wonder why it doesn't work. That's happened to us quite a few times. So one hint, be patient.
Sure. That's a string, but let's see. All right, so let's try it again. Oh, and before, because if it works, magic will happen. So we can see this is empty at the moment. And if it works, it should not be empty anymore, obviously. So I'm now going to run the script. It says test trace created successfully, and it's also giving me the IDs, which is good because I can reuse the IDs if I'm updating the test cases, which will be the second step. So I'm now switching, and don't be disappointed because I have to refresh. And we have 5 test cases. And we have the comment as the content of the test case. And we have in the comment, we have the test case name. So that worked quite well. What I'm now going to do manually is to link the test cases. One thing we haven't looked at actually is the progress panel of this range check element. So we have the status of the requirements. They're all reviewed. We have links to the upper level. So all our requirements are linked to an upper level. We don't have any downlinks because this is kind of the lowest level of our system currently. We have no links to BNBs and we have no test results. And that's what we're going to change now. So first of all, I'm going to link. So if it's in range, it's valid. If it's below range, it's invalid. Should be the first one, yes.
So Torben, while you link, because that just looked, I think, smoother than you and I expected even. So I just want to stress what you just witnessed. It was a one-shot creating a Python file that would access the Spicy API, the documentation of which is publicly available at api.spicyse.com. So Torben took the example from the API documentation. He then took the header from inside Spicy, which gives you, all these authentication codes and so on. He copied those two things, and with one smart prompt, we now have this connection between the test file and Spicy is done. And that wasn't even 10 minutes. I don't know if it went so smooth that maybe the awesomeness didn't hit you yet. We connected two tools using Vibecoding, and I think Torben needed, even while he was explaining it to us, less than 10 minutes to do this stuff. I think I've seen similar examples before. I still think it's fascinating myself. I hope you do too.
Definitely, yes. With AI, everything is possible, right? All right. So let's continue. Now I've linked the test cases. You can see we have now the last 2 bars filled somehow because we now have linked. It's orange because the test cases are still in draft state, not agreed. But let's not bore you with the review process. And the test cases that are not executed. Important in this case is this is not the result of the test cases. That's the result of the requirements. So you can see, for example, our requirement number 2 is linked to 3 test cases. And if 2 of these test cases would be passed and 1 test case would be failed, that would mean the overall requirement would be failed, right? Because if we want a requirement to be passed, we have to ensure that all its test cases or tests are passed. Just one information. So we have one column which is called result. And this is currently on not executed. That's what we can see here. That's what we can see here. And that's what we're going to change next. So let's hope that's easy. To do so, what I'm going to need is the test executable, so a compiled version of our test framework. That is exactly what you saw before in the Gtest file that is compiled into this exe file. And the next thing is a new script. Create a new script that runs the tests from our Gtest file. And updates the test cases result in Spicy SE. One information I need is the IDs. So it's ID 1 to 5. So that's pretty straightforward. Cases with IDs 1 to 5. And I will need this query again. I'm using it from here because I know there's an update. Unfortunately, I forgot the information, so that has to be replaced again. So let's see if that's explicit enough. If it understands that we have 5 tests in the Gtest file and we have 5 test cases in Spicy. And as I mentioned, it forgot the BERA and the organization. Oh, it got the organization. It doesn't have the product ID. So let's just tell it from there. Let's see if that works. So it's executing the binary. That's fine. Parse the output to determine pass-fail status. Oh yeah, maybe I should have given that information. Passed and failed should be fine. Use a GraphQL annotation to update the test cases in SpicySE with the appropriate results for IDs 1 to 5. It looks pretty good. One thing I didn't mention, but it does it out, or it actually found the right setting is we have to pass the correct variable, right? So our test result could either be not executed, passed, or failed. So this has to be ensured that we write passed or failed into the test case. But it got that automatically. I mean, what other options are there if it's not described? So let's see again if that worked. Switching to Visual Studio Code, I have a second file which is empty, copying the source code. And again, just to show you, I'm switching quickly to SpicySE. So these are our 5 test cases with IDs 1 to 5. And the result is currently not executed. And as I showed before, we also see that in the progress panel. That's why it says not executed here for the 3 requirements. So now I'm going to run the script and we're going to see what happens.
"20 minutes later."
Did you see that? Finally, I'm sorry. It took longer than it should have.
But we're still...
Apparently, there were some problems with the tokens and the IDs. That's why I didn't update it correctly. But yes, we're still in time. Maybe just a few words. So now it updated the pass. I mean, once it did it before with fail somehow, and now it did it with pass. So we can see all our test results are passed now through the API. And what we can also see, as mentioned, the test cases are linked to our requirements. If I now click on the progress panel, I can see that our requirements are passed because all of our test cases are passed. So sorry again, that took longer than expected, but I mean, it was live.
It was
sorry,
live.
Robert, I interrupted you.
No worries. Yeah, it was still, so even though it was quite stubborn, and what we saw is that we had 2 use cases of bridging toolings working on an MVP stage, at least in half an hour and a bit. Now we can imagine we can also vibe code ourselves the UI and whatever we need. And we can also imagine that we do this with a lot of other tools. So basically what we want you to take home is digital thread integrating tools to each other with vibe coding and AI has just become so much easier. What we also saw, it's not become a no-brainer, but it's just become so much easier. And if you have a tool that has a great API and an amazing API documentation, like ours does, then it's even easier. So yeah, again, thank you all for coming. It's 1 minute to 3, so there's a last chance for comments and questions. And if not, please feel free to reach out on LinkedIn, reach out on email. We'd love to discuss and talk with you about all things systems engineering. And we thank you very much for coming to this very nerdy, deep diving webinar today. Thank you, Raman. Thank you for attending. Thank you, Pierre.
Thank you. Thank you.
Thanks for your patience.
All right, it's 3 o'clock. Everyone have a good afternoon, morning, night, wherever you are. And see you all hopefully in the next one.